Okay, 1, 2, 3. Do you have my sound? Does it work? Work? 1, 2, 3. Hey, man.
Okay, I think we can start now. I would like to welcome you all to this public defense where Mohammad will present his thesis that is named Water Penetration in Solid Clay Brick Masonry and its Mitigation by Repointing. I am Professor Annika Martinsson, and I will be sharing this session. And I'm professor at the Structural Engineering here at LTH. First, I would like to make a short presentation of some very important persons here, and that is the faculty opponent, Tore Kvande, over there, who will make a lot of questions, I think, later on to the respondent, and he is from NTNU in Norway. And then we have the examination committee, and we have firstly Inge Rørik Dalgard from DTU in Denmark. Welcome. And then we have Magnus Persson from here from LTH, professor also. And then we have Katja Fried, who has been here at LTH, but nowadays she's escaped to Malmö University. And then we have one extra here in the examination committee, and that is Magnus Aas, who's also here from LTH. And also, I would like to say something about the supervisors. We have Miklos Molnar, and we have Eva Björnsson over there, Thomas Gustafsson, Jonas Neklevsky, and Akram Abdul Hamid. So there has been a lot of people involved in this project. So what will happen now? First, Mohammad will present the thesis for about half an hour or something like that. Then we will have a short break. And then after that, the faculty opponent starts with a discussion and questions and so on. When that is finished, perhaps we will have another small break. It depends a little bit how long it will take. And then the examination committee can take questions also. And then afterwards, you all in the audience can ask questions to Mohammad. When that is finished, the examination committee and the faculty opponent will escape to a separate room and have a discussion about the thesis and the presentation. Meanwhile, the rest of us is going over to another building and having a lunch and waiting for the examination committee to come back to us. So that is the procedure now. And with that, I will leave the floor to you, Mohammad.
Thank you, Annika. Welcome, everyone. It's very pleasant to see many of the friends, colleagues, and supervisors all gathering here. And also welcome to those that are attending online but couldn't be here. And also welcome to the opponent and the committee members. Today, I'm going to talk about what I have done during these 5 years of my PhD studies. I try to compact everything within 35, 40 minutes. And the title of this presentation, as you can see, it's about water penetration in clay brick masonry and its mitigation with repointing. As you can see here, the term solid, it means that the thesis or my study only focused on solid bricks, so no perforation or no bricks without any voids or frog bricks. So this presentation has been divided in 3 parts. First, I will go through the background and I will present why we are interested to do the research on this topic and why it's important. Then I will try to present the research questions that I have formulated and try to answer those research questions during these years. And at the end, I will try to present some of the important results. So to begin with, I think everyone in this room agrees that brick masonry is a durable material. It shows a very good long-term performance. Our estimation says that at least in Sweden, around 200 to 300 millions square of brick masonry facade exists. So there is a huge existence of the brick masonry. One thing that I have to mention that usually when we keep the building materials or building components interior without exposure to climate agents, they can last for a very long period of time. While if they are exposed to different climate actions or agents, then there might be some durability or durability related issues. So what's the response of brick masonry to wind driven rain? Why I did a study on the interaction of the masonry and wind driven rain? Depending on the geographical locations, on the weather conditions, and so on, we may have different dominant climate agents. In this region, in the southern of Sweden or in the northern Europe, we have two dominant climate agents, namely as freeze and thaw cycles and wind-driven rain or driving rain, that the rain that is mixed with wind, and then we will have an oblique vector of the rain. Actually, the focus of the test is, as you can see, it's only on the interaction of the masonry to driving rain, but we need always to take into account the frost damage or freeze thaw cycles as another dominant climate actions within this region. What happens when a rain hits a brick facade? As you can see here, a portion of the raindrops will be bounced off or will be splashed back. It means that these raindrops are not available for masonry to be absorbed through the capillary. Nevertheless, a big portion of the raindrops will stick to the facade, and then the process of the absorption will start. Once the absorption continues, it depends on the absorption properties of the bricks. It depends on the wind or even rain intensity, but this process of the absorption continues. If this process continues, then the surface of the wall being saturated. Once it's saturated, we have the runoff or water film on the forming on the wall. And again, if this process continues, it depends on the wind or even rain intensity. It depends on the absorption properties of bricks. Then it may lead to penetration. So penetration is the amount of water or rainwater that reached backside of the wall or behind of the wall. During my tests, I tried to focus mostly on penetration, but also I had some touches on runoff, bounce off, and also absorption. I have to mention that the penetration is mostly a related problem for a brick veneer wall. So the masonry walls with the thickness of half-length brick, usually for the solid masonry walls or the massive masonry walls like this building that we are now in, we may not have the problem of the penetration due to the moisture buffering capacity and moisture absorption capacity of such walls with the thickness of around 370 millimeter. How the penetration may occur? The pores in the masonry will absorb the water through the capillary absorption or capillary suction. Once the water reaches to the backside of the wall or at the end of the pore, the capillary will stop at this end. And then we need some external pressure, like wind pressure, like hydrostatic pressure due to runoff, in order to push the water out. And then if this external pressure overcomes overcomes and tries to breach out this meniscus of the water, this meniscus will be breached out and the penetration will start. What's the impact of the wind-driven rain on masonry facade? Actually, wind-driven rain will lead to increased moisture content and probably penetration in masonry or in the building envelopes, and in turn, we may have a higher risk of freeze and thaw cycles, which leads to frost damage. We may have a higher risk of microbiological growth if we have used some of the bio-based materials, organic materials within the wall frames. And also, it will lead to higher risk of corrosion of the reinforcement, even though this problem has been solved recently for the newly built walls because of using the stainless steel, but still it can be a problem for existing buildings. The other problem or the other issue that we may face is about the erosion of the mortar joints. During the exposure of the mortar joints to wind-driven rain, wind abrasion, and different weather conditions, the mortar joints can be eroded. And as I mentioned at the beginning of the presentation, if we keep a building envelopes or components interior without any exposure to climate agents, probably they last for a very long period of time. But while they are exposed to different climate agents like wind-driven rain and etc., then we may need to think about the maintenance, and it's probably needed in order to keep the building in service. So what is the repointing? Repointing is replacing the existing mortar joints with the new mortar. Usually the existing mortar is raked out up to a depth of around 20, 25 millimeter. It depends on the recommendation and the joint thickness. But usually once the existing mortar is raked out, the new mortar will be applied, and the new mortar should be compatible with the existing mortar and existing brick. The recommendation in Sweden is to do the repointing in the intervals of 40 up to 50 years after the construction of the building or after building's erection, and also when there are some signs of the eroded mortar joints or the cracked mortar joints. Here you can see a building facade that I had a visit on. It's a 60-year-old facade. Here you can see that there are some mortar joints that are eroded, cracked, and you can see some voids here before repointing. Here you can see during repointing. It means that the existing mortar raked out or removed. And then here you can see how facade looks like after repointing once the new mortar was applied to the facade. What's the motivation to do the repointing? There are two main motivations actually exist for why we make a decision on to do the repointing. One is it is claimed that the repointing can mitigate the moisture-related issues due to the eroded and the cracked mortar joints. And the other one is about the repointing can improve the aesthetics of the facade. Regarding the latter, there is a divergence view whether the repointing may improve the appearance or aesthetics of the facade or not. But the focus of my thesis is mostly or solely is to investigate whether repointing can improve or can mitigate the moisture-related issues in building envelopes or not. But one thing that all agrees on regarding the repointing is that the repointing is a costly measure and it's a labor-intensive measure. In a few seconds, I will show you a video that I took during the preparation of my specimens in order to being repointed. Here you can see that the raking out of the specimens, it's a time-consuming and labor-intensive measure. It's only for my specimens with the 3 cores of bricks only, and you can imagine how hard it can be for a real word masonry facade. Now let's talk about the research questions that I tried to formulate during this project and try to answer those research questions. There exist 6 different research questions. Actually, I tried to have a framework of both including experimental and numerical studies, but at this point I have to say that I recognize myself as a person who is interested a lot in doing the experiment. That's why most of the studies that I have done during my PhD is experimentally. Also, prior to starting my PhD, I did most of the research experimentally, but due to the time limitations, cost limitation as well, and you cannot consider all parameters experimentally, at the end of my PhD, I tried to implement some of the experimental results into some numerical simulations. So the first 2 research questions out of 6 is about what are the critical factors, what are the important factors affecting the resistance of brick masonry to wind-driven rain, and under different weather conditions, the resistance of brick masonry to wind-driven rain, it means that the response of wind-driven rain and the brick masonry to wind-driven rain, and it means absorption, penetration, dampness, and etc. So how is the interaction between these two? The next research question that I try to formulate and answer is about what about the cracked masonry? So if we have some cracks, imperfection within the masonry, how the response would be or how it affects the penetration and the absorption response in a brick veneer. The next 2 research questions are about the effect of repointing, whether the repointing can improve the resistance of brick masonry to wind-driven rain or not. And also in the next question, I try to find this answer that it is rational to make a decision on repointing repointing or in all scenarios, or there are some scenarios that we may think twice before making a decision on repointing. And the last one, I try to somehow implement and use the experimental results that I found during these years. I try to improve the hygrothermal assessment of the building envelopes and also how it can be used in order to improve the risk assessment or the judgment regarding the moisture related issues of the building envelopes, mostly with the brick veneer. So about the experimental setup, this is the test setup that I have used mostly during my research studies. Actually, this is the final stage or final development of the test setup. As you can see here, it didn't look like that much nice at the beginning. It took a lot of time and lots of trial and errors to reach to this test setup. This test setup, as you can see, it's equipped with different equipments or the gadgets. As I explained here, there are two scales, as you can see here. And also in the front scale, the specimens is placed on top of that. And here there is a nozzle which exposes the masonry face here to the water spraying rate, simulating wind derivative rate. And then this scale was for measuring the moisture content or the water absorption in the masonry specimens continuously during the test. The other scale at the behind, as you can see here, this scale was placed there in order to measure the penetration, so the amount of water that could be collected from backside of the specimens. Then this test setup is equipped with the camera, and the camera was placed there in order to detecting the dampness on the backside of the specimens. So where or when on the backside of the specimens the dampness appear, so we could trace it with this camera. Then the test setup is equipped with different water pressure regulators and water flow meter in order to regulate the water spray rate and water flow meter, water pressure. I try to consider different type of specimens within the experimental studies. I don't go that much deep through different parameters that I consider, but here you can see that there are specimens that built with two different type of bricks and three different type of mortar joint profiles. These specimens prepared without any known cracks. Probably during my presentation, I will use the specimens without cracks and the cracked specimens, but I have to emphasize that always we have the crack in the masonry, which can be related to the shrinkage, to the moisture gradients, temperature gradients, workmanship, and so on. So the term uncracked masonry, it means that the masonry without any known cracks. Within the next experimental campaign, I tried to create some of the artificial cracks. Actually, I was responsible only to do the designing of the specimens, but all of the specimens preparation or building of the specimens was done by professional bricklayers, so I was not involved in this process. But here I tried to create some specimens with cracks, but with artificial cracks. It's very hard to get access to real world cracked masonry. And even though if you have access to that, it's very hard to have a control on the measurement of the crack width and the crack size, even though here it took a lot of time and lots of trial and errors to reach somehow a specific crack width once we prepare the specimens. Then in the next experimental campaign, I try to tell myself that, okay, within the first 2-3 experimental campaigns, I answer to these questions of what is the response of brick masonry when it's cracked and when it doesn't have any known cracks. But then what's the response of the brick masonry when it's repointed? What's the impact of the repointing on this response? So as you can see here, the repointing is done in the next experimental campaign. And as far as I mentioned that I did a part of my PhD numerically at quite final stage, I tried to use two hygrothermal software which are used for hand simulations, Woofy Pro and Delphin. Actually, I have used mostly or have worked mostly with Woofy, but for the last paper, because of some limitations within Woofy, I had to use Delphin. I tried to use different kind of building wall assemblies or building envelopes, as you can see here. You can see here this one on the left, it's a timber frame wall with the brick veneer with the thin insulation. It's an existing wall, quite built during 1950s, 60s. Here you can see a masonry cavity wall with the autoclaved aerated concrete as a inner leaf, and also the brick masonry as an outer leaf. And this is an existing wall in Göteborg, in Gothenburg, and this is built around 1960s, 70s. And here is a newly built wall. Again, it's a timber frame wall like this one, but with the thicker insulation. It's a newly built wall recently. Now let's focus on some of the important results and discussions that I have obtained during these years or based on the experimental and numerical studies. I have to mention at this point that from now on, each slide that I'm presenting, you can see that there are some research questions at the top of each slide. And these research questions means that this slide is trying to answer those research questions. And then at the bottom of each slide, at the bottom left here, you can see the number of papers. And it means that this slide or these results is further included and discussed in these relevant papers. So here is about the response of the masonry to wind-driven rain or to water spray rate. And the response here, it's about the absorption. Here you can see on the y-axis the absorption, so the amount of water that is absorbed in masonry. And on the x-axis, we have the time, the exposure to water spray. Each test took around 23 hours and including 6 different cycles. So each cycle was around 210 minutes of exposure and then pausing between each cycles, and it was repeated 6 times. As you can see here, there is absorption, pause of 20 minutes, absorption, pause, and etc. to the end of the test, which took around 23 hours. One thing that I could conclude based on these experiments that I've done is that the water absorption in masonry is mostly dependent on the brick absorption properties, and also on the water spray rate is less affected by the mortar joint profile. Here, for example, if we compare these 3 curves that are colored in red, black, green, you can see that the pattern or the moisture response or the absorption response is quite similar. They are the specimens with the same type of brick, but different type of mortar joint profiles. These specimens were exposed to a spray rate of varying between 2 to 3 liter per square meter per hour. It means that around 2 to 3.5 millimeter per hour of rain or wind-driven rain. And then in the next campaign, I tried somehow to double this spray rate. This one is around 6 to 7 liter per square meter per hour of rain. I have to say that at least in Sweden, it haven't or hasn't been occurred. I don't know what happens with this climate change impact, but I think it rarely happens to have such intensity of the rain during 23 hours of the exposure. There is one study done by Sandin where he measured the wind-driven rain intensity in Gothenburg. Gothenburg is the location in Sweden or city in Sweden with the highest exposure to wind-driven rain. And the maximum wind-driven rain that he could measure or record, it was around 6 millimeter per hour of the rain. And it was only one rain event with the duration of the 1 hour. But here you can see that the test continues for 23 hours. Now, what's the impact of the cracks on the repointing? So here about the specimens with the artificial cracks. Again, on the y-axis, we have the absorption, and then on the x-axis, we have the time of the exposure. Again, here you can see that there is a absorption and then pause between each cycle, absorption, pause here, and then it continues to the end of the test. Actually, the effect of cracks on water absorption was rather limited. As you can see that there are 5 different curves denoted in different denotions from GO to GO9. GO, it means that the specimens without any known cracks, and GO9, it means that the specimens with the crack width of nearly 0.9 millimeter or 1 millimeter. As you can see here, the pattern or the behavior is quite similar, except this GO9 at this point, which is this black dotted curve or line here. As you can see at the beginning of the test, the amount of the absorption is the same in all specimens, but after that, there is a deviation. At this point, the surface of the masonry is saturated. And once it's saturated, for the cracked specimens, there is a clear path for water to enter and then redistribute or absorb through the masonry. While for the specimens of G0, so the specimens without any known cracks, there was not that much clear path for water to enter and to redistribute. That's why we have a lower absorption rate at this stage, but as you can see that at the end, the absorption is quite in the same range. So the conclusion was that the effect of cracks on water absorption was rather limited. Then what happens with the repointing? What's the effect of repointing on water absorption? Actually, the results that I will explain shortly, it was not very well aligned with my hypothesis. My hypothesis was that the repointing may improve the resistance of the brick masonry to wind, the riven rain in terms of penetration. It may reduce the penetration, but I didn't expect that the repointing, because during the repointing, you only change the 20 millimeter outer part of the mortar. I didn't expect that the repointing can improve the absorption or reduce the absorption rate. Here you can see the curve, which shows 6 different curves. Again, on the y-axis, we have the absorption, and on the x-axis, we have the time of the exposure. These three on the top, they are the specimens before repointing, so prior repointing, and these three are specimens after repointing. They exposed to a similar water spray rate. As you can see, let's take this G09 with the blue, this one, and then G09R. It means that the specimens that with the crack width of 0.9 millimeter, but after repointing. So if I compare this blue curve with the green curve, you can see that, for example, after 4 hours of the testing, the absorption prior repointing is around 15, 16 kilogram per square meter, while in this one is around 9, 10 kilogram per square meter after repointing. And it shows a reduction in the water spray rate after repointing. Actually, I thought a lot about it and discussed a lot with the Miklos of what happens. I didn't go that much deep through the reasons, but I thought of 2 reasons. I tried to explain it in 2 different ways. Once we do the repointing, the new mortar is applied, and then the brick layer has a very good accessibility to compact the mortar. So somehow the mortar joints are somehow sealed, so there will be less absorption through the mortar. And also we think that during the repointing, the mortar is raked out, and then there will be some dust or particles of the mortars, and then we need to wash the masonry specimens in order to being repointed. And during this washing, the dirts may be solved in the water, and then they might be absorbed by masonry and clogged some of the pores within the bricks. That also may explain why we have this huge reduction, both because of the sealing or plugging effect in the mortar joints and also clogging some of the pores within the brick. Here I mentioned that the test setup was equipped with a camera. The camera was placed there for detecting the dampness. I don't go that much deep through the results here, but here you can see there is a high concentration of the nodes close to the brick mortar interface and in the vicinity of the head joints. Each node represents one specific specimen, so each node represents one unique specimen. And you can see that there is a high concentration of the nodes. So it means that in most scenarios, or nearly all scenarios, the dampness appeared close to the mortar interface in the vicinity of the head joint. And it shows a lower resistance of the head joints to wind the riven rain. Now let's talk about the cracked specimens and the specimens after repointing in terms of the dampness. As you can see here, they are the appearance of the dampness for cracked specimens, and on the right, the appearance of the dampness after repointing. Actually, again, these results was very surprising, and it was not aligned as well with my hypothesis. Here, I expected that when we have some cracked specimens, for example, these ones with the crack width of around 0.9 millimeter, I expected that in all scenarios, the dampness would appear in the vicinity of the cracks. But as you can see here, even though we have many cracked specimens, The dampness appeared in some of them in the vicinity or close to the crack, while in some of them it occurred still in the vicinity of the head joint. And it may show somehow how comparable head joints and the cracks are in order to provide a low resistance passway to wind driven rain. Then what happens after repointing? You can see that it's expected that when we fill the mortar, we fill the cracks during the repointing, there is no clear path for water to enter, so there is no dampness appearance in the vicinity of the cracks. Still, you can see a high concentration of the nodes in the vicinity of the head joints, but it's somehow scattered, as you can see here. There is a big difference between these two. As you can see here, most of the dots, it means that most of the specimens are colored in red and orange. It means that the first dampness appeared after 1 or 2 hours of the testing or exposure to rain, while here most of the dots are colored in green and blue. And it means that the first dampness appeared after around 4 to 5, 6 hours of the testing, and it shows that the repointing can or could reduce the absorption rate and could postpone the appearance of the dampness on the backside. One thing that I have to mention that the dampness or the start of the dampness is different from the start of the penetration. So the penetration here may occur after 1 or 2 hours, while the dampness may occur after 1, 2 hours of the testing, but the penetration might occur with some delay. And also, once I check the correlation between the time to penetration and time to dampness or first appearance of the dampness, I couldn't find a very clear uh, correlation between these two. Now here it's one of the important results that I obtain and I try to implement in some numerical simulations. Here you can see a curve including both water absorption on the y-axis on the left and then water penetration on the right axis on the either right axis on y-axis. Here also you can see the exposure during 23 hours of the testing. So the purple one showing the water absorption and the black line showing the water penetration. Actually, it was consistent in nearly all specimens without any cracks that the water penetration started once the moisture content was above 90% of the saturation level. So it was nearly saturated, but you can see due to the moisture buffering capacity, moisture absorption capacity of the masonry, the masonry didn't let the water to leak out or to penetrate. And this absorption rate or these amounts are differ between different type of bricks. It depends on the wind-driven rain intensity, etc. But this correlation with the absorption and penetration was somehow consistent between all specimens without any known cracks. So what's the effect of crack in terms of penetration and in terms of what's the effect of cracks in penetration and also repointing on penetration? Actually, here you can see now, from now on, I explain the penetration on the y-axis and then the time of exposure on the x-axis, and the same again penetration on y-axis. So this is after repointing. They are denoted with R, and here you can see the exposure time. By a glance, you can see that there is a clear reduction in the penetration, and it's somehow expected that once there are cracked specimens, you fill the joints during the repointing, you expect that there is a reduction in the penetration rate or penetration amount. But one thing that was very interesting is that the effect of repointing on specimens without any known cracks or without cracks. Here, this one, GO, so this red dotted line, it's the penetration in the specimens without any known cracks, but before repointing, here you can see the penetration is nearly 2.5 kilogram per square meter per square meter. While here the penetration of those specimens, so GOR, it means that the specimens without any known cracks, but after repointing, here you can see that the penetration decreased to around nearly 1 kilogram per square meter. So reduction of the penetration from 2 to 1, it means that around 50% reduction in the penetration rate due to the repointing. even for specimens without any known cracks. I have talked a lot about the lower resistance of the head joints in order to providing a pathway for water penetration. Actually, this figure confirms somehow our observation. These are the figures that I took during raking out my specimens. So these head joints and the joints were raked out in order to being prepared for the repointing. Here you can see that, for example, this one is the mortar head joints is somehow well filled, but comparing to that one, you can see a very clear voids, gaps, and even I would say that there are some highways for water to penetrate. Also, one thing that we cannot be sure about, for example, the one on the left, you can see that this exterior part or this part is well filled. Probably if we rake out a little bit more, if we dig a little bit more, again, it may not be that much well filled as it looks like here. So it's somehow these figures and these condition of the head joints show how head joints are important and why we have in most of the cases, we have the appearance of the dampness in the vicinity of the head joint, or why in some of the specimens, the penetration occurred through the head joints. Then I mentioned that I did a part of my study numerically, so I tried to implement some of the experimental results based on the cracked specimens and repointed specimens into some numerical simulations. Here you can see the impact of repointing on a timber frame wall with the brick veneer. You can see how the reduction is in the mold index due to the repointing. So the blue is before repointing and the orange is after repointing. I tried to consider different locations based on their weather conditions, average temperature and rainfall. And also I tried to divide the masonry or the condition of the masonry veneer into two different categories. So the walls in a good standard condition and the walls in a deficient condition. It means good standard condition. It means the wall with the rather limited eroded joints, cracks, and quite in a good workmanship, even though it's very hard to find it out. But also, on the other hand, we may have the walls with the deficient condition. It means poor workmanship, poor maintenance, and with rather a lot eroded and cracked joints. As you can see, that repointing could reduce the mold index in these walls, but also in some scenarios like good standard condition, the reduction is rather limited, while for walls in deficient condition, the reduction in the mold index is more significant. And we could say that for locations with the high exposure to wind river rain, like Gothenburg, or orientations with the high exposure to wind river rain, and also for walls with the quiet deficient conditions, the impact of repointing is rather significant. So at the end, I try to reach to this final conclusion that given the fact that repointing is a labor-intensive and costly measure, we need to think twice before making a decision in order to do the repointing. So I try to recommend to think about the partial repointing. Partial repointing here, it means that rather once now the decision is made to do the repointing is done for all facade orientations, but we can do the repointing for the facades that are mostly exposed or that have higher rate of erosion or the cracks. And also we may think of the partial repointing in terms of if we have a building wall, if some parts of the building is only eroded, we may do the repointing on that. I also mentioned at the beginning of this presentation that it is claimed that the repointing may improve the aesthetics of the facade. If the appearance of the facade does matter, we may think of some cleaning methods or some other maintenance methods, and then it will give a fresh look to our facade, and probably it can postpone, or we can understand that there might be no need of doing the costly measures like repointing. So at the end, I want to thank the contributors and also the funders of this project, both SPUF and TMPB. Without their contribution, this project couldn't be done, and probably I was not employed here and was not here to present. And also, I want to thank all my supervisors from Miklos, Jonas, Akram, Ivar, and Thomas. And I need to give a very special thank to Miklos for all of his support during these 5 years. I'm very grateful to him. Also, I thank Ture for accepting to be the committee member. Actually, the paper that was co-authored by Ture was the first paper that I read at the beginning of my PhD. That's why I remembered his name at that moment. And also I want to thank the committee members to accepted to be here within this disputation from Katia, Magnus Persson, Inge, and Magnus Ost. Thank you.
Okay, thank you very much for this presentation. Now I think we have a short break. Let's say we will be back here at 11. So, and then we continue with the discussion. Thank you. There is a guy over there who says where I'm supposed to be standing, so I try to follow his orders. Oh, welcome back then. And now we continue. And I gave the word to Tore, and looking forward to an interesting discussion between you two.
Thank you. Is it working? Yes or no? Is it okay? Yeah, thank you. So, first of all, congratulations for being in the position for defending your thesis. Your thesis consists of 2 conference papers and 4 journal papers. And 2 of the articles are published in highly recognized journals. So I find that impressive. It testifies solidity. And in addition, I can see from your thesis you had made quite a lot of other publications. So you have been really productive. I also want to say that I have enjoyed following your research throughout the PhD project. I will say I have followed it paper by paper because I have been the reviewer of at least 3 of your articles. The first, the first one passed, I think, rather easily. The next one was rejected by the editor. I don't know why it was rejected because I was rather positive. But I could see you have published it in another journal. So that's good. And the last one I reviewed, I didn't never get a final decision from the journal, but I can see it's published in another journal. So I guess it was rejected, that one also. But again, I was positive. But I have some objection, and I'm glad to be here because now I can discuss them with you. So that will be good. When I read your thesis, it seems like you have been following as strict planned, everything's following up each other, and it's heightened you together. Was it planned like that, or how did you end up with the structure and with the papers? Mm. 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 Mm.
Thank you. So I jumped to this step about, okay, doing the crack. And then since the project is mostly related to repointing, I said, okay, now do the repointing of specimens to see what happens. Then at some point, I got somehow tired of testing. I think I test 2-3 continuous years, including the weekends. So it took a lot of time. And then I said, okay, now let's have some touch also on numerical studies. Then I got the help from another supervisor, Akram. He was mostly active in the building physics related aspects. So it was semi-planned, actually.
Semi-planned. Thank you. But yeah, the industry seems to be, the topic is very relevant for the industry. And I think you have a good collaboration with the industry. It seems like that. Can you tell me something about that? How involved have they been in the planning, in the material choice, and so on?
They always support the project, and I had a regular reference group meeting with the industries. So this TMPB, the Masonry Render Association in Sweden, Tungt Murat, something like that. Hutsat Murat, I don't know actually. And then also, since the project has been funded by SPUF, so it should have a very close relevant for industry. And also, if this was actually one problem for me as a PhD student, that I could find it very hard to find journal papers regarding the repointing, because repointing is something technical and something that industry is trying to use, but going towards a scientific path for the repointing in terms of publication, it was very hard. But then I had a lots of support from this. There are many, and can name two main, Anders Plansen and Frey, that helped me a lot, from facade group and these facade contractors and consultants and so on. And also I had one co-supervisor. He's a licentiate, and he's a consultant in the masonry. So I had a lots of collaboration and regular meeting with those. At the beginning, Miklos tried to help me to get involved in the masonry gang and community. And then I tried to keep it during these years. And then for some materials, they were involved in providing the materials and the bricks. For example, there is no brick factory any longer in Sweden. So most of the bricks are produced based on the Danish standard. So that's, and we are interested in the Swedish format, which is 120 millimeter. Then it was a bit hard to get access to those. And then, for example, in the first campaign, I had specimens with one type of brick with a very low variability. And then I wanted to order it for the second campaign, and it was not any longer produced. But then also for some mortars, they provide it, but somehow, for example, when you have different kind of company sectors, like different mortar producers, they want, for example, NHL, one needs one type of mortar, one needs the hydrophobized mortar, and so on. It's hard to meet all of the requirements and to satisfy all. So it's mostly about we or me decide as what I want to do, and then the industry helps with the consultants and with the providing the materials and so on.
We will come back to that, because when I started to read or started to look at your first papers, I was a bit surprised of the material choice, especially the mortar, but I will come back to that. Okay. But I understand that something is, it's a standard or normal in Sweden, but I'm not used to exactly those mortars from Norway. Okay, your thesis is titled Water Penetration in Solid Clay Brick Masonry and its Mitigation by Repointing. It took me quite a long time to understand what you were looking at. For me, I was reading solid masonry. But now I understand this is what we are talking about.
Yeah.
Is the shape of the brick. But what you're really looking at is veneer walls.
Actually, at least for the name of the thesis, it was first water penetration in brick masonry. And then I discussed with my supervisor and think that, okay, it's not in all kind of masonry. We only limit to, because I got this question, many of the existing facades in Sweden are perforated bricks. And also we have many massive masonry walls. Then I picked up the solid in order to remove or to disregard these perforated bricks, frog bricks, and different type of bricks. But actually, once I took this decision, I had this issue that many of the terms that use for the massive walls, it's massive walls or solid walls. So the solid brick masonry can also refer to a massive walls, which is not. And then we had this idea of the veneer walls in the topic. And then, I don't know, I tried to think that, okay, most of the specimens that I prepared or all of the specimens that I prepared was limited to 3 cores of bricks. I got quite a lot of criticism or comments on why I was limited to these 3 cores of bricks. So I told myself that I didn't do the real test on the veneer walls. But as you said, I totally agree. It's veneer walls because I implement all in the veneer walls. And because of the thickness, it's only for veneer walls.
And your conclusion is about veneer
walls.
Exactly. The reason why I had some problem in the beginning thinking on solid masonry is that you use solid masonry in your introduction, referring to the massive walls. But maybe you can make a sketch of a veneer wall. I missed that in the introduction. So we can have some discussion about it.
I'm too poor at drawing, but let's see. I tried to learn it during these years from Miklos, but not successful.
We blame Miklos if it's ugly.
Yeah, exactly. Yeah. More here. Yep. So if we have, it depends on the type of the wall, but generally for the veneer walls, we have this is the, so this is the mortar between and the brick and so on. Then it depends. There is air cavity, or it can be and not be, and then it can be a cavity walls with a double masonry leaf or like
if you make a drawing of what you have studied in your papers.
It was one with the, I think that one was with the autoclaved aerated concrete, so AAC. Like this was one wall in that I did a study on. And then some plastering gypsum board at this part. So this was an existing wall without any vapor barrier and so on.
So we have the drain. From that side.
Yep.
And we have water absorption.
Yep.
And we have penetration. What happened then with the penetration? How is it built, the whole wall?
Actually, this is a disagreement, or at least when it comes to numerical studies, there is a disagreement. But in reality, what happens, I think if we have a very clear cavity here, if there are some penetration from these joints here, due to the runoff, it will be formed here, and then it will be somehow collected here. And if it is a good drainage, it can be drained out. But what I've seen in reality, even now, the facade of my building that I'm living now, it has some problems, so they need to remove the brick veneer parts. I could see very clear that even it's, I think it's a veneer wall, and then this installation backside. In some parts, the brick is somehow in a contact with the insulation. And as I mentioned in some papers, if we have some eroded joints, if we have some extruded mortar joints, then this water, rather than being fall down or run down, it may reach to this part.
Yeah.
But mostly in a theory part or in a good masonry veneer wall in a good condition, it will be run down and then collected at the bottom.
Yeah.
I
Is
think.
it a system there?
Sorry.
Is it a system ensuring the water to go out of again from the?
There should be, but not necessarily. So
Because I'm used to it's a membrane
yeah,
and it's an opening
exactly, to drain. Yeah.
and also in the top. So moist have the possibility to dry out. So it's open in the bottom and the top. Is that the same in Sweden?
Yeah.
So what are the effect of that?
I think here in this wall, if we have some pressure equalization, and then if we have, as I said, if there is no clear of the extruded mortar, then the penetration, I think, will be drained here. And then all of the impacts of the penetration into these kind of hydrothermal performance should be somehow disregarded. But yeah, but and
the pressure difference over the air wall.
Yeah.
What do you think?
It's generally what I've seen or what I've studied based on the, for example, normal wind speed and so on. I think generally it's around 10, 20 Pascal. It's very rather limited. So if we have a normal wind or even rain events, and with the not normal, even with the wind speed of, I think, 4 or 5 meters per second, I think it only produced 10 Pascal, which is so low. That's why also the reason that I didn't use the standards or the existing standards in order to do my testing, because those, they use a very intensive pressure.
Thank you. That's some of my next questions about that. And I was a bit confused in the beginning when I started to read your thesis, because I was prepared for solid masonry. And the pressure difference over that wall is something quite different. I have tried to measure the pressure here in real walls, and it's almost zero. But it's hard to measure, but it's very limited. And that affects the penetration.
Yeah, but I think this is what is, I think previously, or most of the knowledge about the penetration is that it happens when there is a air pressure difference between the exterior and the interior, or between these two.
And the corners.
Yeah, exactly. And one thing that I think recently shows, and I think it's quite, I could found it based on my experimental results, where I didn't have that much of air pressure difference. It was quite zero. It was only some deep pressure due to the spraying rate. Actually, one thing that was interesting is that in many specimens, I could record the penetration. And then what is now, it's very hard to assess. What they call it the penetration, and the pressure is due to the hydrostatic pressure due to the runoff. I actually calculated somehow the runoff on the surface, and then it can give at the max 10 Pascal. So this pressure due to the runoff is also very limited, or nearly zero, with this normal rain intensity. Then we comes to the head joints. And probably you have a question for that part. But then we come to the head joints. If there is a buildup of a pressure, then it may lead also to some pressure difference and may lead to penetration.
That's true.
Yeah, that's why in many of the specimens that I tested at the beginning, because I didn't apply extreme wind pressure or air pressure difference, I could see, it was very interesting. I took some videos. The water was here, so at this bottom very edge, and then I could see that it tries to leak out or to go out, but it didn't. So the water as it was at this very bottom end of the masonry, because it was not very well filled, but the water couldn't be formed a drop and then leaked out. And then it's because of the no pressure difference or no difference that could overcome this pressure to breach the meniscus of water.
You've seen the research from Schlappe. Then we had the possibility to have a pressure difference over the specimen. And then we pushed a lot of water through.
Yeah.
Because it was too open. Okay, you can sit down again.
Thank you.
Okay. I have some question about your test method.
Yep.
And you started answering it. You are testing rather small pieces of masonry and not large element or panels. Or why did you end up like that?
Actually, the limitation or the design for going for the 3-course masonry specimens. First, what I've seen in most of the studies that I have some criticism about with respect to you, that mostly one walls are being tested. So because it's very time consuming, it's very hard to test the real wall or at least a large scale wall specimens. But if we consider many of the uncertainties that we have for the workmanship and different material properties, like even if you test a single brick and then check the water absorption coefficient or other parameters, you may end up with 10-20% variation in the results. So if you go for one specific walls or 2 walls, I think the decision or the results that you get out of them is not as solid as if you do many replicates. This is one thing to say, okay, going for many replicates. So doing many specimens. And then at that point, because of, I think we had some limitations in the lab to do the test and the preparation of the specimen or to do the testing, then I told myself to go for rather limited specimens. But then I saw some studies that by Ricci, I think, where he considers 5 course of bricks without head joints. Then based on the literature review, I told myself that probably the head joints are relevant, or they are. And then we try to add 1 head joints in our specimens. So this is one thing. And then also, you know, that each specimens weigh around 12 kilogram. And I have also back problem. And even though if I didn't have, I think for a normal person, these 12, 15 kilogram, because I did a test every day, it's quite in the range that is somehow acceptable to do so. So that's why I try to limit myself to 3 course bricks with only 1 head joint.
So it's very much about the accuracy of the measurement. I like that you have tested a lot. When you are doing small tests like that, I think you should compensate by testing a lot. So I like that. But you made your own test setup. Why didn't you use a standard method?
Generally, the standard test, first, what I wanted to have is that I said, okay, if we have a rain events, generally the rain covers the whole masonry facade. In some of the test setups or test standards, there is a pipe somehow over the top of the specimens, and then it will create a runoff. And then in some cases as well, that there is the most important reason that I have to say that I wanted to measure water absorption. In existing test setup, you need to put the specimens or the wall types in the frame and then seal it. And then you can apply the pressure and so on and the water spray rate and then measuring the penetration. While I, at least from my side, and also we had lots of meeting, whether it's possible to do so, but I couldn't reach to a conclusion. So that's why I wanted to have a free-standing specimen. So put it on 1 scale for measuring absorption and then another scale for measuring penetration. Otherwise, we end up in those test setup. Regarding the condition, I can talk as well if you want.
Yeah, thank you. But your research question, they are about wind-driven rain. But you are testing with spraying water and neglecting the wind in your test setup. Why did you skip the wind? And how does lack of wind influence the validity of the conclusion?
And yeah, the short answer is that applying a wind pressure or air pressure difference in my specimens or not applying is a limitation of this study. But one thing that I tried to do is that I went through like the ISO standard, the ASHRAE standard, in order to find out first I went through the SMHI for the getting the weather data, the wind data, and the rain data in Sweden. And I tried to consider different locations in Sweden to reach to a range of wind-driven rain. Actually, most of the wind-driven rain events was even around 1 millimeter per hour of the rain. And also in many cases, the wind that co-occurrence with the rain at the same time, as I said, the wind average, I think it was around 435 meter per second. And it's quite consistent with the measurements, at least in Sweden. And then it's not, because the test setup that is mostly used is ASTM standard, and it's based on the hurricanes in, for example, Florida. And then I told myself that based on this weather data that we have, based on the most frequent wind-driven rain events that we have in Sweden, the wind pressure that should be applied, it's maximum 10, 15, or 5 Pascal. Actually, it was hard to do so in my test setup. So I did the trial and then I got error. But also I measured the pressure difference between the exposure phase of my specimens and the backside with the, so anemometer. As far as I think, as far as I put the nozzle with some distance to the specimens, then it could create some pressure difference. And it was interesting that it could create a pressure difference of up to 10 Pascal, which is, I think, 3 meter per second of the wind. And then I realized that when I went through the literature a lot, I realized that the penetration is mostly occurs due to the runoff. Even though if we apply the air pressure difference or wind pressure, we may expect a higher penetration, but mostly the occurrence is due to the hydrostatic pressure, probably. That's why I stick mostly to the hydrostatic pressure and just having a runoff on the surface and the regular exposure and not applying any air pressure. And I think if we applied frequent wind pressure, it didn't affect the results.
Because you are testing
Venerable.
I think that's the answer.
Yeah.
The short answer. So you think your test results are really, and it's valid for, it's possible to have a conclusion on the near walls. But if it had been a solid masonry, as I started with when I started reading the thesis, I have been
it doesn't make sense.
Much sense. But we should go back to the material. And it's normal to choose a masonry mortar with M2.5.
This is, we can ask the industry later on, but I think in Sweden mostly, or this M2.5 is mostly used for repointing. It goes for a strength of lower M1 or even M05, I think. But I think for the pointing or for constructing a veneer wall, I think M2.5 is the frequent one.
But you made your specimen with M2.5.
Exactly.
Yeah.
Yeah, exactly.
And you had NHL 3.5 as the after pointing mortar. Is that also common or just?
The correct answer is I don't know how much common is, but as far as I said that I have this reference group meetings from different ideas or different facade constructors. Actually, it was to say that because there is a now a new interest in doing or in using the natural hydraulic lime mortar, and then we had to use, for example, for repointing, I didn't use the NHL, I used M1, but for after pointing, I used NHL. So we said that, okay, just having a mortar, the regular mortar as a base, and then for the very outer part, only adding NHL, natural hydraulic lime mortar, to see how it affects the resistance to rain. But for the repointing, I used M2.5 as an existing mortar, and then for doing the repointing, I used M1 actually.
How do you think choosing another mortar had it changed the results, or?
Actually, I have applied for a funding, and then I can give you the exact results within honestly about that, because I think the most important thing about the mortar is about not the bond strength with the brick, but it's the contact with the brick, how well the contact is developed with the brick. Because most of the penetration, as also, even if we have a very extreme rain events, as far as I saw in the literature, we don't have, or rarely we have the penetration through the bricks and through the mortar. Mostly it occurs through the brick mortar interface. And then the property of the mortar is important in the terms that to have a good contact with the brick. So we need to have a very compatible or match brick and the mortar types. But actually, I was asked in one of the papers, my thinking was that we may not have the penetration due to the type of the mortar itself. It's because of the contact with the brick, and I think so.
That was a good answer. I hoped for that one.
Yeah.
When I read your diagrams, I sometimes it's a recommendation for next time. You should use the same color at the same specimen, and so you don't. If you want to compare figure 16 and 17, there should be not.
Right.
Yeah, you should use colors that's easy to understand. What's the same? I think that's for your whole thesis. If you look at figure 21, it's on page 51 for those who have the thesis. Is it the same? I see 4 different colors there. Is it the same brick, or is it 2 bricks or 4 bricks, or?
Actually, the type of the 2 on the top, there are 2 different type of bricks. So top left is one type of brick, and then top right another type of brick. But then campaign B is the same type of brick, but it's because I did it in a dark room, and then it was very hard to reach the same color. So each one on the top is the same as in the bottom, but it's one unique specimens only. But each dots for representing for one unique specimen. So I tested around 10, 20 specimens, and then I projected all in one representative specimen.
And the middle row, the surface structure there seems to be different from the top and bottom brick.
Can you repeat it once again?
If you look at the series 2, and lower to the right, the bricks against the head joints seems to have a different surface structure.
Yeah, exactly. It's not, as I said, that it's I tested in the for example, in campaign A for series 2, I tested 20 specimens and I took one of the specimens as a background of these dots. And then for the other one, I took the same type of material, but exactly not the same specimens. But
so it's not that you have broken the brick.
yeah, I did it. I did it.
So we see the
yeah,
the
the
cut.
part that you can see that, yeah, exactly. We cut the bricks, or the bricklayer did it. It was very hard, and then we put 2 half bricks for the head joints, or for this second course.
You don't think that will affect testing? Because it's not the normal way of laying the brick. If it had been a whole long wall.
But I think as far as we go, because if we have a bricks and then we cut it in the half, we put the nice face of the brick still at the exterior, and then the other that is half in the backside. I think it would be the same in the real wall. I think so.
Yeah.
Or
as long as they are at the same size.
yeah, actually, it was one thing that is valid quite for all specimens, honestly, that even though I insisted a lot to the bricklayers that to do the job as not they do it in the real world, so have a good control on the size, on the mortar joint thickness, and so on. But still, it was, I understand their size, that it's very hard, but sometimes also I couldn't have that much control that to reach, for example, once they cut the bricks into 2 halves, then it was not necessarily all the time the same size of the half bricks. Or the joint thickness, if you take a look at that, honestly, even though we try to put different distancers or spaces to reach the same size of the specimens, but even though it was hard or was not achieved successfully.
Okay. If we go back to the test setup again, testing cracked masonry, or we should start where the cracks appear in masonry. The crack that's interested for you, where do they appear in a normal masonry?
One thing that we don't have that much, or probably not having a through crack. This is one thing that we don't have a through crack. But then I thought or spent a lot of time to find out how we can create the cracks, or how we can create artificial imperfections in bricks, honestly. So it's not a real world cracked masonry, as I mentioned also during the presentation. But most of the cracks that we expect is also in the mortar joints. So due to the shrinkage, for example, due to some hairline cracks we may have the cracks also in the head joints. And if we have the cracks due to the lack of the shear strength and so on. So generally having a through crack, it's not what is have in the reality. But at least I couldn't find out a very convenient way to create a specimens with have a good control on the width or the size, and then representing somehow reality. We thought that, okay, to break down the specimens and then to put them back together in order to have, this is what is done in many experimental studies. So they break the specimens, they load the specimens, and then they break it into 2 parts, and then they put some spacers in between and put it back in order to have a good control on the width. But still, that one is also a through crack.
It's difficult. I don't know how to do it. I tried it once in my early research, but what we did, we put the brick mortar, and then we put a layer of what's the English word? Bandage. bandage. And then they laid a upper brick, and then we had the possibility to take it away. And then we took away the bandage and put a brick again. Then you had a more natural pathway through it. So not yeah, you have a really opening. It's not a crack, it's the opening.
Yeah, exactly.
But it was, yeah, I stopped that research because I didn't find a good way of doing it. But I've been walking around looking at cracks on masonry, and I think this is something for Thomas. Yeah, it's a part of masonry.
Yeah.
You have tested crack here.
Yeah.
I made them there. Why didn't you make it here?
I just reached to this. Actually, I did some tests. I didn't include on that because we said that it might be easier to have because this is a half bricks. We said that if we put these plastic strips here, it's only this part of the brick will have some mortar, and probably the specimens will be detached because the thickness of the width of these cracks here, it was around 50 millimeter. So we didn't have these half bricks didn't have the mortar at this part, and then it may not develop the bond with the lower brick. But here is the full length brick, so this part probably doesn't matter. But the location does matter, whether it's here, here, or here. I didn't include it in the thesis, but I tried. It was also hard to find out, but I tried to rotate the specimens to see then what's the effect. In some specimens, it was quite lower penetration as it's expected because of the runoff and the gravity, it's mostly expected to have the penetration here. While if I rotate it, then it becomes here, and then there will be less.
Because I see more cracks here than here. But if you have made them here, you had some problem with flow, water flow.
Yeah.
If you had put your arrangement there, you have avoided the flow problem.
Yeah. Actually, this is only the reason that we came here, that, okay, I thought that the bond might not be developed here. But as you said, yeah, here it was a difficulty that the mortar flow just filled somehow the gap. Yeah, I think it took, I tested more than 20 specimens to find the time. When is the time to remove this plastic strip? Was it successful? Yeah.
Okay. But I guess that was one of the reasons one of the paper was reacted, not by me, but someone else. I didn't like your gateway for water. But it's a bit hard to draw the conclusion from those tests to the real situation, because the cracks are very strange.
Yeah, I agree. I try to honestly soften a lot of when I write or when I try to discuss, I try to soften my tones or the words a lot, that to say that this is artificial cracks, and even they are not cracks, they are imperfections, even probably not very realistic imperfection.
Do you have the possibility to show the figure 31 for the audience?
Yeah.
You started to discuss that one during your presentation. I found that figure very interesting.
Was it included in
it was in the presentation.
Okay,
it was that one.
Oh, okay. Yeah.
first, when I saw it firstly, I was surprised because of the big difference between that shape and that shape.
Yeah.
And I start to compare it and with the after pointed curve, because I expected it in the beginning to be almost the same, but it's a big difference. And maybe you can repeat your thought about the difference.
Yeah, sure. Probably Inge would have many comments on this part. Actually, this is one thing that was, as I mentioned, it was very surprisingly at the beginning, when once I get the results, I talked with one of my co-supervisor, Jonas, I thought that something might happen with the test setup. Again, I used the specimens before repointing, and then I checked the tests, I checked the results, and I got the same results as the beginning. Then again, I put the repointed ones, I get this one, but still I was not being sure. I repeated many times to be sure that this is correct, because there were many difficulties with the test setup. But then when I reached to these results, this is each curve is the average of around 13 specimens. So it's each curve for 13 specimens. The first thing that came to my mind was that when you do the repointing, or the bricklayer do the repointing, he or she applies the new mortar, and then there is a very good compaction of the mortar. So the mortar that I think I took the videos and I was there. So he applied, probably in a normal brick work, they don't apply that much of mortar, but then there is a space for him. He could really tighten the joint and then seal it somehow. It was a point of reduction in the absorption. Then I checked the results as well and discussed it with Miklos. And then we said that even if I neglect the joints, so even if we say that the joints are fully sealed without absorption, still there shouldn't be this much difference. And then we go for the different hypotheses, different fancy hypothesis or scientific hypothesis. For example, I've heard that also Inge did some work on that for the bricks that are exposed to weathering, or if you check the absorption coefficient, the part that is weather is different from the other side because of some pores are clogged and so on. Then it came to my mind, even though my specimens is not eroded or it doesn't expose to weather condition for a long time, but then we said that, okay, probably some of the pores during washing of the dust and the mortar that is remained in the specimens during the raking. We wash the specimens, probably some of the pores are clogged, some of the pores in the brick are clogged with that. And also one thing that came to my mind, if you do have the specimens before repointing, the contact is not that much good, so the water can enter and then can be absorbed from top of the brick. So if we have here, it's up here. So if we have the mortar here, then the water will be absorbed by the face of the brick and also the mortar. But also if the contact is not very good or very well compacted mortar, the water is entered a bit and also can be absorbed from that face of the brick. While if we have a very good compaction and then filling of the joint, probably this contact is very well formed, and also it can somehow reduce the entrance of the water through this interface. So it's mostly the absorption was by brick, and probably, as I said, some pores are filled or some pores are clogged, and also these joints are tightened. Because as I said, even if we remove all of the joints, so no absorption in the joints, still I couldn't justify this reduction. So something else happened, honestly.
Yeah, we are making we are doing the masoning. I'm not a mason, but they, in Norway at least, they take the brick like that and the mortar, and then they squeeze it on top, and then they squeezes like that. And that's one of the reasons we have weak points in the corner, because it's not that compact as the other place. And it's better contact here than there. But what you are doing when you take away the outer part of the mortar, and then you repoint. I'm not sure. Are you able to get a good contact here, or do you just make a lot of airports here?
During the repointing,
Yeah.
no, I think it's quite well successful in filling that part.
But how do the air escape when you are repointing it?
During the repointing, just the bricklayer had the trowel, and then he pushed the mortar inside. So here, and then compaction. So it was not like the normal bricklaying when they use a big trowel to put the mortar and then do the bricklaying.
Because if you had more airport there, then you can have it might be an explanation of the difference between the curves.
Yeah, you're right.
Maybe.
Yeah, you're right.
But that maybe someone else in the audience know better than me. Because it will be it break the absorption.
Yeah, it breaks the absorption. Yeah.
Or delay it. Okay, we are talking a lot about mortar now and the interface. And I think I think we should start to talk about the modeling.
Yeah.
Because you are saying in paper 4, page 4, although modeling a brick veneer as a homogeneous layer involves limitation, it has been shown that this simplification may provide acceptable results. And I miss the references there.
Okay.
Because there are no references about that
Okay.
statement.
Yeah, I will go back to that. Just regarding the bricklaying, as you said, once they do the bricklaying for the head joints, this is one difference that I think, based on your papers and recommendations, that is differ from Sweden. I think you recommend this buttering technique. So they apply the mortar in the edge of the half bricks and then, or the bricks, and then do the rest. But here, I think, or in many cases, it's the pushing technique. Mostly. I think, as you wrote, also the Norwegian recommendation is the pushing technique, but it shows that the buttering technique, and it makes more sense that it gives a better interface or better contact.
Fredrik Schlaper showed a big difference between those techniques. So,
relating to your the statement, I know the reference. The reference is by staff rules, and I put it in my papers definitely, but I don't know why I haven't put it in the test. It's probably I repeated many times. Honestly, when you go for 1D simulation, you need some justification of why you go to the 1D simulation, because for a brick veneer, you need mainly 2D simulations. The conclusion that he drawn was that he did both laboratory experiments and the real world weather conditions. His conclusion was that if you do the experiment in the lab, there is a clear difference, so you cannot model it 1D. But if you get a real weather data, so with the normal rain events, with the normal temperature and so on, then there is the difference between 1D and 2D is rather limited, so you can consider it as a homogeneous layer. So this is one thing that I went through. So I think at least in one of the papers, or I put this one because it was commented a lot why I went for 1D simulation and not considering Brink, even though in one of the papers I considered the 2D as well.
I didn't find it. I haven't read. I don't know what study stuff roles did, but it's a huge difference between the properties here, the mortar, and the interface. But you didn't look at all at the interface. Yeah, why do you think about that?
Yeah, at least I think the easy answer to that, if we want to go for that, probably the best or the most accurate answer would be the 3D simulations. And then because of the time consuming and cost consuming, we limit ourselves to 2D and then we go one step back. But in a real world case, we have different conductivities or different because of the distribution of the pores, we have different resistance for the water transport or water flow, and definitely we have different conductivities. That's why if we want to really think about it, that's why I mentioned as well, if you just like these bricks that we have, if I push the water or if I drop the water in it, there will be not probably a penetration on the other side. But if we have, and also the conductivity at this interface is much faster. So I think your PhD student and you co-authored the paper, Kanarud, you did a study. And also it's somehow confirms with this dampness, that the dampness appeared always close to the brick mortar interface. It provides a lower resistance, so higher conductivity for water. And yeah, definitely it's effect or it affects the results. But if, as far as I wanted to implement only penetration, I didn't mention that I consider only the number of penetration. So it doesn't matter that much for my case.
I think Knarud, he succeeded quite well in modeling the brick very well and the mortar very well. And he also quite good took care of that situation, interface, but this part we didn't manage to swallow. So in many ways, looking at it as a homogeneous might be good enough, but modeling is very, very difficult.
Yeah, completely agree. Because if we want to think of I think if we want to think about the moisture content or the moisture distribution, then the one is definitely lacks because we cannot use this waterfront or water sharp front in these masonry specimens or masonry walls. But I think, as I mentioned, if we go for penetration, we need the rate of penetration. So then we can somehow have some limitation.
I'm glad you focused on the experimental part. And I'm glad you did some numerical simulation also, but I'm really glad you stopped because it's very complicated. It had made a big change of your objective and scope. I want to jump to the conclusion.
Yep.
You have a conclusion number 8.
Yeah.
Repointing can be considered as a maintenance technique to reduce moisture-related risk in building envelopes with clay brick veneers, particularly those in deficient condition and located in areas with high exposure to wind-driven rain. What is high exposure to wind-driven rain?
Yeah, it's somehow hard to explain because at the time that I writing this probably thesis, I had mostly the context of Sweden in my mind. Sometimes in my papers, I try to consider also different locations like Norway, the west coast of Norway, I think Scotland with the higher wind-driven rain intensity. But as far as I try to do the study mostly in the Sweden, by high exposure to wind-driven rain, I mean some locations like Gothenburg, the west coast of Sweden, comparing to east coast of Sweden, where you have a higher rate or higher exposure of wind-driven rain.
Maybe you could show the figure I gave you here.
I will check it. Yeah.
Because this is a wind-driven rain map showing annual wind-driven rain from the most exposed direction. It's made for Norway, but we added Sweden as some part of Sweden, not the most important part of Sweden, I can see. And a little of Finland also. Yes, Gothenburg is, as far as I know, the most exposed location in Sweden regarding wind-driven rain. But if you look at the map, do you have some reflection?
A lot. Actually, yeah, I think this was one of the map also. I think you included in your study that different countries have different wind-driven rain maps. I couldn't find it for Sweden, specifically for Sweden, a wind-driven rain map or wind-driven rain index.
No, you got it.
Yeah, exactly. I saw that one. Actually, the main difference is that much more, because I think in Norway, as far as I know, Bergen is the most exposed one in the wind-driven rain. And I think in Sweden, we can say Gothenburg, at least for the major location. And I think the Bergen, the wind-driven rain is 3 times the average annual wind-driven rain is 2, 3, or 4 times more than Gothenburg. I'm not sure. Stig mentioned in his paper. But this is one thing that definitely the wind-driven rain intensity is much severe than. One thing that you mentioned about the high exposure, and also one limitation that we have with these wind-driven rain map, or generally these studies, they are generally averaged for 1 hour of the wind-driven rain, but we know that generally for the intensive wind-driven rain events, we have a shorter period of the rain, but with the very high intensive rain, while we take the average. So this is one thing that I think all of these numbers should be increased, while then, as I mentioned, that there will be much higher wind-driven rain and expectedly more penetration in the west coast of Norway. And one interesting thing that my supervisor Jonas helped me to do so, it was that now once we do this kind of map and try to get the weather conditions, we use the weather conditions by stations, and usually they are located in a quite far distance from the location of the study. But there is one map that I didn't put it my thesis. I think this map, the coefficient of the variation, if we decrease the grid to 1 kilometer to 2 kilometer, even there is 20% coefficient of the variation between each measurement points. And then if you apply it also in the numerical simulations or in the models, then you get, once you have much more wind-driven rain comparing to Sweden, and then you have much more variability, and then you average it in hour if you have a shorter period, so it will be much more higher. And
so if I go back to my first understanding of your title, Solid Masonry, I think you have quite many buildings with solid masonry and bare brick in Sweden.
Yeah.
We don't have that at the west coastline of Norway, because it's the wind-driven rain is too high. So you must most of the brick masonry there traditionally is covered by rendering. So we have additional protection. But the West Coast, that's the high exposure to wind-driven rain. It's not Gothenburg.
Yeah, definitely. I think, as I said, it's 1/3 of Norway, 1/3 or 1/4 of Norway.
But your conclusion number 8, you also use the word maintenance technique.
Oh, you are the one that put that comment.
I had trouble with that.
Yeah.
But I think I got the answer from Thomas yesterday. But maybe you can explain that. For me, it's not, repointing is not a maintenance technique. In Norway, it's a way of repairing deteriorated mortar.
I agree that it's in a more general case, it's a repair technique, as I mentioned, but also I think, at least in Sweden, the perceive or the perception is that as far as the repointing is done as a regularly or frequently done technique, so as far as I've heard that in Denmark, it's not as, or in Belgium or UK, the repointing is not as common as in Sweden. In Sweden, it's somehow assumed that, okay, do the repointing in many cases after 40, 50 years. So it is something that is already included in the building maintenance. But I agree that it's mostly a repair technique.
The funny thing was, when I arrived Lund yesterday, I went for a short walk, and the first building site I came to was a repointing mortar project.
Okay.
I found that funny. And I never see it in Norway.
Okay.
Very, very strange. Okay. Someone almost sleeping, I can see, so maybe we should stop. But if you want to sum up in the way you look at your thesis, what is your most important contribution to the Swedish construction industry?
I think the most, I don't know, once is about that to differentiate between the dampness and the penetration. So a wall may got damp, and it's not necessarily means the penetration or forming some water drops on the backside. The other one is about not Swedish building industry probably, but mostly the consultants that using the hydrothermal simulations or the moisture consultants that think a lot about the moisture buffering capacity of the masonry. So in many cases, we don't have the penetration, or it's very rather limited. And then when it comes to repointing, even though I showed a lot that the repointing can reduce the moisture content, can reduce the mold index, but if I want to give a straightforward answer to that, probably the gain that we obtain by doing the repointing is not that much significant. Like as I showed, that the mold index can be reduced, for example, from 1.6 to 1 even, or from 4 to 3 even. But in any cases, we have a failure in that wall, or we have a high threshold of the mold index. So repointing can be beneficial in many scenarios, but in many scenarios, even though if it reduces the absorption rate or the penetration, it's not an irrational decision to do so.
I think that's good advice. Okay, we should bring this up to an end. As I understand, I'm supposed to give a sum up of my impression of your work at the end of our discussion. So I consider the laboratory work to be the greatest strength of your thesis. It seems reliable to me. You have tried to control the variables in a good way. I like the way you have limited stuff and just focus on what you have done. I find the objective of the thesis well defined, and the scope of the work is well within what I expect from my PhD thesis. And the results are presented in relevant journals, some of them with high reputation. 6 papers are, yeah, I think way beyond what I expect from a PhD at my university. So I find that impressive. Making a PhD is a research education. And then you have tried several methods, not just lab, but you also have done some numerical simulations. And I think you also demonstrate a good overview of the most relevant literature. The topic of your thesis is quite wide concerning literature. But I think you have a good overview. My biggest criticism is the somewhat, I will say, narrow focus on Sweden and Swedish condition. And I had liked to see a more comprehensive assessment of the relevance of the artificial cracks to the natural cracked masonry. I had liked to see a more tougher discussion about that. But in sum, I find your work very, very well done, and you make good reflection during our discussion, and I have learned more about your work. Next time you should use veneer walls in the title, I think. So thank you very much.
Thank you. Thank you. It was a very nice discussion.
So thank you very much. I think we all learned quite a lot from this discussion. Not only that it rains more in Norway than in Sweden, but also something about brick walls and differences between different brick walls. But now I think I'll leave the floor to the examination committee. Someone who wants to start here? No. Then I start with you, Inge. You have some.
Yes, I would be happy to start, but I'm not so familiar how you used to do it, so that's why I not volunteered. So you would need to bear with me. So first of all, Mohammed, obtaining a PhD degree is primarily a result of the finalization of a successful research education, where the student demonstrate how he or she can work systematically and satisfying with a research topic, just as reporting the findings in a written format in a clear and thorough including relevant and critical discussion. This is entirely in line with my understanding of your work. Congratulations.
Thank you. Yes.
And I could say just the same for your presentation. I think you made a very nice presentation. It was clear and included your findings. So that was nice too. And then I just have some few of my own interest areas I have a few questions on. And maybe I would just start with what one of the last thing talked about, and that is your contribution to the field. And you were asked, what is the most important findings you made? I'm pretty sure that as you obtained the financing from the industry, they were looking for some specific answers. And I guess that the reason for focusing on Sweden was that you got the funding from Sweden. I may not be correct, it's just a guess. But so you find out, you looked at different parameters and you looked into how they influence the water transportation. So now my question to you would be that damage description is hard. And you suggest that you should focus on just repointing specific areas. So could you say more precisely, when would you advise for repointing? Because I guess that's the question they were looking, or the answer they were looking for. When should we repoint? You said you should not do it just because it's 40 or 60 years ago that this building was erected. So you should look specifically the at the building, and how should we do so? In your first paper, your conference paper, you made a review on how is these mortar joints evaluated. And you came up with different methods. And in your last paper, you say that you should look specifically on your building. So maybe you can just elaborate on, would you still choose the same parameters as you suggested in paper 1, or do you have some additional things? So I'm looking for specific advice. I know it's not a fair question to ask, but I mean that's what they're looking for. What should the crack width be, and so on? Something specific. When, yeah.
Yeah, thank you. Actually, I had several visits for the different real world masonry facades or different buildings. When you go for, take a look at those facades or inspect them, you see that some parts of the facades are more eroded, some parts are not. Then at least here you can relate it to the orientation towards wind or even rain. But if I want to give a very concrete answer to that, I would say that if you don't have a specific moisture-related issues after a period of time within your building, definitely don't do the repointing only because of the time. Just postpone it for another 5 and 10 years. If something happens, then we can think about it. Then we can see, okay, this is one disregard of, okay, not do the repointing if there is not problem because of only the time or some erosion. Because if you don't have any mold, if you don't have any moisture related issues, don't do the repointing. Then it comes to that if you have a moisture related issues, whether should I do the repointing or not. And I think at this point, it's very hard precisely to say that if the problem of the moisture is due to the penetration itself or not, because it might be due to the other leakage problem. It can be due to the condensation somewhere else. It can be due to something else. But as far as I would say, I think for the sake of the only having some more eroded joints, or because there are still many buildings in Sweden, at least, or in many countries that have been built 100 years ago, they don't show us, and they are not repointed, and still they are in a good function. Probably they need to, the energy and performance needs to be improved, but at least they haven't shown a moisture related issues and they are in a good function. So that's why I think that even in those specific cases, we don't go directly if there is a moisture related issues, go directly for repointing. And then if we choose the repointing, I think we need to think of the facade orientations.
So even though that 1 centimeter of the mortar joint is missing, you still would say wait until you have a problem and mold in your sleeping room.
No, actually 1 centimeter is quite a lot, because 1 centimeter is a lot. One thing that I see, for many of the cases, that's why also I said partial repointing. I meant for the orientations with the eroded joints, and also some building parts, like mostly at the edges, because there is a higher intensity of the rain, wind or even rain, there will be more eroded joints. And in the facade that I show you, it was a 60-year-old facade. In some parts, there was a real voids, it was not even eroded. Some parts of the mortar detached. So I say that to even, and sometimes we may have different type of the cracks due to the settlements or different moisture gradients. And I think then we need to fill those gaps, cracks, and do the repointing. But it's not somehow the repointing that we think of. So it's if we have this part of the building which is eroded, then do the repointing for that part. Then I think the statics does matter, and it needs a because the new mortar is not matched then with the existing mortar, and the appearance does matter, but it's another step. But 1 centimeter is a lot, so definitely.
So maybe that would also be a new proposal you can make. When is enough enough? Because it can be very costly to wait until you have mold inside.
Then
Yeah,
it's
yeah. But yeah, I also understand what you say, that you should not just do repointing because it's this year, but there needs to be a problem. But still, it would be nice to find something in between, a limit where you say this is definitely too much. Now we need to do something that could be of high practical use for advisors.
totally agree. Thing I mentioned in the first paper, I didn't investigate it as that what's the relation between the depth of the erosion with respect to water absorption and penetration. Exactly, we need a curve or something to find the points that at which point the erosion of the joints will be critical in terms of penetration.
Yeah, so that could be nice to have. Yeah. You showed that the water absorption properties, they are highly influenced by the material properties, and that you showed that on a graph in your presentation. I found it in table 3 on page 40. Maybe I can convince you to get it on the screen.
Yeah, sure,
please,
sure.
If you remember which one it is. Yeah, that is table 3.
That's good.
Yeah, you're right. This is not a. Sorry, Mohammed. It's on the figure 16 on page 45. The material parameters are mentioned here, but the interesting part is the figure. You also showed that one. This one.
Yeah.
Yes. And yeah, what you told, that is that the main difference between the lines, maybe you can just repeat it.
Yeah.
Because you do it better than I do.
Yeah, here we have, if I get the pointer back, okay. Here the test was done on 2 different type of bricks. So bricks with quite higher absorption capacity and higher absorption coefficient, and with the lower one. These 3 curves, the black, red, and green, are series 1, and they are the specimens with the high suction bricks, one type of brick. The rest from series 2 G1A to series 2 G3, so these 3 curves and these purple one, are the specimens with the lower suction bricks comparing to first series. So this is another type of the bricks. And then the absorption in these type of specimens generally is lower in this type comparing to that part of the specimens. But also it depends here, if we compare this purple one with these 3, that's why I consider it G1A and G1B. So these purple one with these blue one, they are the same type of specimens with the same type of break and joint profile, but they expose to different water spray rate. and we can see that this one, at 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 the end, the absorption is, yeah, it depends on the absorption capacity of the bricks, and there is high variation. But the higher absorption rate in the purple dashed line is because it's exposed to higher spray rate.
Thanks. That was exactly what I'm looking for, because what you show here is that it makes a huge difference which brick type you use. So I'm just puzzling. In the description I found here, and that was what I found on page 40, you write that you pick two common Swedish brick types. And what I then see is that the brick type 1 has a density of 1,800 kilo per cubic meter, and type 2 has a density of 2,050. And now my question is, does this reflect the, yeah, typical Swedish bricks? Is it typical to have such a high density as for your brick type 2?
I think I think so, and also I checked the recommendation of where the bricks are used. I think even the bricks, this type with the lower density, it was because of the absorption capacity and the absorption rate. It was not recommended somehow to be used in the veneer in some cases. But this one, I agree that it has a very high density. But I tested another type of brick with the same quiet density, but it was with the lower absorption coefficient. But I think at least those from industry can confirm or can deny it. But I think this is the brick that is used. I've seen in many bricks, they are in 1,900, 2,000 kilogram per cubic meter of the density for the solid bricks. Yeah, I don't know if I right on that. This Miklos confirmed that this is the two or think 1900 is a quite valid value.
I find this interesting because in Denmark, 1800 would be high or around average. So we would also have lower densities. So how would you think that would be reflected in if you made new experiments with bricks that has a lower density and a higher water absorption? What would the result be of that?
Very good question. Actually, yeah, as there is a somehow correlation between the density and then the porosity and water absorption coefficient. If we have a lower density bricks, then most probably we have a bricks with the higher absorption capacity. And this is somehow also valid for the Danish bricks, where because of the clay, the bricks are quite high suction. And as far as I saw in the literature, there is one good study that I have to mention. Probably, I don't know if he is alive or not. The first study that is at least published and done on water penetration is back to 1938 by Fishburne, so around, yeah, 80 years ago. And then he also by Ricci, they considered around 1,000 of specimens, different kind of parameters and so on. Still, they said at the end that the workmanship is the most influential parameter. But the brick also is very influential. The type of the mortar is less influential, but the higher absorption rate of the brick is, the higher penetration is expected. And there is another study by Groot in Delft, where he used a very high suction bricks, so with a higher initial rate of absorption, and he could measure and observe the penetration through the bricks, which because of those bricks I couldn't saw. But I think if, at least based on his investigation, if we use a very high absorption properties bricks, you may expect also penetration through the bricks. And in general, I think there is somehow correlation between absorption capacity, absorption properties of the bricks and the penetration amount.
And the same goes a bit for your mortar choice, because you have chosen mortars, and I'm sure you're right that they are typically used. The industry, they like to use design mortar. It's easy to calculate the final result, so they're most popular. But if in the future we use more lime mortar, lime mortar is not so dense, as normally the design mortars are based on cement mortars. And the same goes a bit for your hydraulic lime mortars. Also have the same properties as the cement mortars. They develop more slowly, but they also end up like that. So if you use mortars with a higher content of lime, I would expect them to be more open and maybe have a higher water transport through the mortar joints. Could that significantly change some of your results if there are more water transport to, mortar joints?
I think both yes and not. I think in terms of the absorption or the moisture content distribution, definitely it affects a lot. And as I mentioned or answered to Tura, I think then we need to think about the contact or interfacial zone, how it's developed, because I could see in all of the specimens that where the water starts to leak out or to penetrate. And I think also if we have a cubic samples of the mortar or the bricks, as I mentioned, in many cases, if you spray the water on them, you rarely expect the water to leak out through the specimens. But I think the important part is the compatibility between the bricks and the mortar. But I've seen also the studies showing that the lime has leads to a higher penetration as well. But definitely for moisture content, because of the higher absorption properties, definitely you need to or you expect the higher moisture content. And then, yeah, it's if I want to shorten it, I try to somehow set that the penetration starts when the moisture content is nearly 90% of saturation level. And then if you use a lime mortar, then you reach to that saturation level earlier, comparing to the masonries using rich cement with the lower absorption. So it's a point that where and when you reach to the saturation of the masonry as well.
I agree. So if you had all the time in the world, it could have been nice if you also have included as some kind of a more lime-based mortars to see the range for when this this starts.
Yeah, thank you.
Yeah. I think I used my time. Maybe just a very small, short remark, and that is how could you this nice drawing you made on the board, where you discussed on what was the reason for the lower water absorption by repointing, and the question was, are the joints fully filled? So how could you have checked if the mortar's joints are fully filled and there's an optimum contact? That's it.
During the repointing, you
Or
mean?
afterwards, after you
I
have,
mean, once the repointing was done.
yes, and you want to evaluate your experiment.
I think again, it's very hard. I don't know actually. I think I will go for raking out the specimen to see that how it's the match of the added mortar, the new mortar with the existing mortar. This is one thing, and also that considering what Ture said, that probably there is some air, and then this uh, there is the cut in the capillary absorption. I think I agree as well that once we did the repointing, it's done after, I think we did it after 1 day of raking out. There are too many different standards or recommendations on when to do the repointing, and it affects also a lot. So I think once the repointing is done, at least in my specimens, it's done after 1 day. Sometimes it's recommended to wait it 2 days. Some days probably, I don't know, in industry, probably they wait even more because they want to rake the whole facade. I don't know, I'm not sure. And then it's, I think, affects a lot the compatibility or bond of the new mortar with the existing mortar, and might be some gap there and some air contact.
Do you know cross sections?
Yeah.
Yes. So what I would have done, that was to take out a sample, cut out a sample, and make a cross section of the intersection and see how the contact would be.
Yeah.
then you could get a
Yeah,
good
exactly.
answer.
Yeah. Yeah, yeah. If I slice it as a cross
Yeah.
section, I can see the states there. Yeah. Thank you.
Okay, thank you very much for that. You get a lot of tips here about what
Yeah,
to do
a lot.
in future. And then, Katja, perhaps?
Thank you so much. First of all, I would like to thank the Division of Structural Engineering for inviting me. It's truly an honor to be considered to this committee, so thank you so much for that. Then I would like to thank you, Mohammad, for writing this pedagogical thesis. I truly enjoyed reading it, and I truly enjoyed listening to you today. So please consider to teach in your in your new career, because I really think there is a teacher inside of you. Yeah. Okay. So I've read your thesis, and I would like to talk a bit about your cracks, your artificial cracks. So I do recognize the difficulty to try to simulate the real world, and you do need to make a lot of choices. I would like to hear some of those that you've done to decide that your cracks should look like this.
Thank you for your nice words. It was very pleasant to hear. Actually, for the having the cracked specimens, as I mentioned in the literature, or mostly they built specimens, usually, for example, a cubic mortar samples, and then it will be structurally loaded, for example, by 3-point loading, and then it will be cracked or broken, and then there is a we can put a spacer to put back the specimens in order to control the width of the crack. It was a bit hard in our specimens to do so, and also I thought that if we do it, then we have a very thorough crack through the whole bed joints. Then with Miklos, we talked a lot about it. Okay, where to put the mortars and how to do it. Sometimes we said, okay, if we just break the mortar, or if during the bricklaying, we ask the bricklayer just not to fill a part of the mortar and so on. I think it gives a more reality perspective if you just put some part, the gaps or the voids. But I think it's very hard then to control the size of those voids and the cracks, and then it's very hard to justify it in the results. Even though when I reached to, okay, let's having some through cracks, and then it came to my mind using these plastic strips. And then we found that when to do it and where to put it. We wanted at the first time to put it in the head joints, because if I think the cracks created in the head joints, there might be more hydrostatic pressure and might be more penetration. Then I somehow frightened about the detachment of the specimens, because they are only 3/4 specimens. I think if we had, or I had a larger specimens, then having a cracks, it was easier to create in one of the joints or in one of the locations. But with 3/4 specimens, it's very hard to do so. And then I end up with these plastic strips. I said, okay, how to reach to different width. I try to add different plastic strips. So 1 layer of plastic strips, 4 layer of plastic strips, to reach a specific thickness, even though it was very hard to reach the specific thickness. So honestly, we prepared around 150 specimens, and I tested at the end around 60, 70 specimens. So I disregarded lots of specimens, because once we created the cracks were fooled by the mortar, because the mortar was not that much hard. But sometimes the mortar was very hard, and once I removed the plastic strip, the mortar detached at that point. So, and also in some parts, it was a clear opening, but then it was a blockage of the mortar in the middle. So I disregarded many specimens, but I ended up in these. specimens, but still you can see that there is a very high variability in the results. But this is how I ended up, honestly.
Yeah. So, yeah, you worked very hard and we can see that. So, of course, but then still you aim to simulate some, older brick walls or something like that with imperfections. So it's not only cracks, it's sometimes poor workmanship, it's sometimes other stuff. So what kind of imperfections do you think you really simulate here when you do your artificial crack like that?
Actually, if I really want to compare it with the real world facade or real world masonry, there might be like I took a photo from one researcher or one consultant at the DTI Danish Technical Institute, where during the repointing of the facade, he took a photo from a facade and how it looks like during the repointing or raking out the mortar. They looked like my specimen, so lots of voids, cracks, and imperfections in it. But if I want to compare myself with the real masonry, always the outer part or exterior part of the finishing part of the wall is very well filled or compacted. So we don't have that much of specimens with the through cracks at starting from the exterior to all through the interior. But I think once I did the repointing, I feel the 25 millimeter of this length of the crack, and the rest was still remained as unfilled because I didn't do the repointing for the whole length. I think those specimens somehow can uh, show the reality of the masonry real world, where you may have a very good finishing of the wall, but if you dig a little bit more, then you can see some cracks, some imperfections. I think those specimens are more representative comparing to these cracks with the true artificial cracks.
Okay, yeah, thank you. Because now you have this data, right? And you have this control data, different sizes, with all your hard work. Now it would be really interesting to try to correlate that to a more reasonable crack, right? So it could be a next step. There's a lot of good examples for next, more research, right? But to try to crack them in another with the temperature perhaps or moisture distribution or stuff like that, and then relate that to your measurement with those artificial cracks to try to correlate and use the numbers that you have got.
Yeah, that's a very good suggestion. Actually, didn't came to my mind. I think for this with temperature gradients or these curing conditions, we can have some cracks and some imperfections within the mortar or within the mortar interface with brick. And then, yeah, we can correlate as well to my experiment.
Yeah, yeah. Because we really would like to have some new data in the models, right? And you will have already suggested a new moisture criteria for the penetration, but you didn't suggest anything about the cracks. So why was that?
I try to suggest this criteria somehow. At least I try to correlate the moisture content for the cracked specimens and the start of the penetration. As it's expected, the higher the crack width, the lower saturation level you need for the whole specimens in order for penetration to start. But as I said that for this, as far as we don't have this kind of cracks in the real world masonry, I found it very difficult in implementing in the real walls. That's why in the last paper, I tried to group all of the cracked specimens. So I grouped all of the cracked specimens with different crack width and so on. I said walls in a deficient condition. And then walls without any known cracks, I try to categorize them as walls in a good condition. And then I try to compare somehow these two, because even if I say that this crack width is critical, this crack width is okay, I think if we send an inspector for inspecting a wall, it's very hard to measure the cracks, to find the cracks, and to categorize this. That's why I try to give somehow a qualitative assessment that, okay, this wall is very much cracked, too many eroded joints, then it's categorized as a deficient condition. While another one with a better condition, with the less erosion and so on, can be categorized as a good condition. And there I try to implement some criteria. But actually for each specific crack, giving a specific criterion, it was I think it was unscientific based on the size of the type of the cracks I created.
Great. Thank you so much.
Thank you. Thank you.
Okay, then we go on. Magnus?
Yes, thank you for your presentation and your thesis. And again, I want to congratulate you and your supervisor for a very well done job. My expertise is not in brick walls. I normally study water penetration into the soil, which is kind of similar. You have clay bricks, so made out of clay soil, and you have rainfall on top, or not on top. You have horizontal rain, basically, so horizontal flow. But still, it's quite similar. So, and again, like the other members of the committee have said, your thesis is well written, and even for me as a non-expert, it was quite easy to follow. And of course, I can recognize good quality research work, even if it's not in my expertise. So well performed, well structured, literature review, experimental work, modeling work, and in the end, some kind of recommendations that you want to make. So, I mean, that line of research is quite logical and well performed, I think.
Yeah, thank you.
So, a few of the best questions have already been asked. So I will try to find at least some of my questions on my list have not been asked yet. So I will focus on the experimental work. So we have already talked about some issues with the experimental work. In experimental work, you of course want to have something simple that you can do all over again, and you want to have controlled conditions, but still you want to have an experiment that can reflect what is going on in a real world scenario. And there has been some issues discussed, for example, that we have no wind speed. So if you were to guess now the effect of don't having a wind speed in your experiment, will that overestimate or underestimate water penetration?
Yeah, yeah. Thank you again for your compliments. Thank you. Really enjoy hearing the kind words. Actually, definitely the results underestimate the water penetration in the absence of the wind pressure or air pressure difference due to the wind. But I have to mention that we have to think of that the frequent wind pressure or the wind speeds that we have that occurs at least in many locations. Norway, as Ture showed, or some regions in the US, they are very extreme examples of like having typhoons or hurricanes or very high intensity wind or even rain. But in many situations, we have a quiet normal wind speed through the wind or even rain events, and it leads to around 10-20 Pascal, as I mentioned. There are many good studies also done by Ture and mostly done by Straub, a Canadian researcher or professor, where he tried to categorize the penetration based on different between different air pressure difference. So definitely the higher the air pressure difference, the higher the penetration is. And at some point, the behavior is not linear, so it will lead to non-linear. But at some point, the penetration would stop or wouldn't increase that much with the increase of the wind pressure. But I think if we want to, this is one thing that I discussed with my supervisor as well. If we want to go for the standards test in order to have the design of the walls or to go for a very extreme condition, then definitely we need to apply the high air pressure, because it may occur every 100 years, every 50 years within the life cycle of the building. But if we want to think about the repointing, then we need to think of the frequent and daily wind and the rain events that we have. And in those scenarios, I think and I believe that the wind doesn't affect that much the penetration in a very low air pressure difference, because I think the pressure difference due to hydrostatic pressure is more significant. But as I said, in some specimens, I could see the water at the very end of the specimens, and it needed a push just to breach the meniscus. Some probably if I apply the wind, even though we have to consider the resistance and the thickness of the specimens, but probably that wind pressure may overcome and may breach that meniscus and penetration started. But the short answer, yeah, is underestimate the penetration.
So a small underestimation, but in normal conditions, insignificant.
Yeah.
So next issue, and it has also been discussed, the scale of your wall or your specimen. And we have heard why you choose that size, but what about the size? Do you think the size of the specimen gives you an underestimation or overestimation of the water penetration?
Yep. Actually, I got many comments during the submission of the papers on that part. Put the comments. For example, the Swedish brick standard, the size is around, the thickness is around 120 millimeter, while the Danish format is, I think, around, for example, 110. And we may have also the some, I think, Belgium, it's around 90 millimeter. So the thinner the wall is, it's the moisture criterion, the criterion that I propose, this 90% saturation level, I think it's still valid for all thickness of the masonry. But we have to think that if we have a thinner wall, then we reach to that moisture content or saturation level earlier. So the thinner the wall that we have, the earlier penetration may occur. This is also somehow can be seen with this kind of wall, which is very thick, and then we don't have any penetration. So somehow the penetration would start earlier. And I think if we have a quite high pressure difference, then the thinner walls have a lower resistance to this wind pressure, and probably again it increases the penetration. Regarding the size of specimens, I have only one head joint, but in many kind of specimens or in the real world specimens, this kind of my specimens, you can see there is only one head joint for 2 half of bricks and for these 4 kind of bricks, but we have more head joints for the for if we have a real wall. So I expect that, and as far as the head joints are the low resistance pathway for water, so they have many voids and cracks. I think in the real world walls, we may expect more penetration because we have more head joints per brick, I would say. This is.
Okay, thank you.
Thank you.
And if you then look at the height of the sample, a normal wall is quite tall.
Yeah.
It can be several meters tall, whereas you are smaller. So I would assume that there will also be at some point a vertical flow of water within the wall, making the water content higher further down the wall. So if you had a much taller sample, how would that affect your result or the penetration?
Yeah, I totally agree with you that if we have a taller wall, then the water film or the thickness of this, when the runoff is formed, there is a higher accumulation of the water in the bottom, and the thickness of the water film is thicker. So, or comparing to the upper part of the wall. And I think this is somehow observed that if you have a taller wall, you have a more accumulation of the water and you have a higher built up of the hydrostatic pressure. And I think it may lead to higher penetration. Yeah, I agree.
Yes, I agree as well. So finally, what has not been discussed is the spray rate. Well, it has been discussed, but the spray rate, you have a constant spray rate for about 1 hour, whereas rainfall and wind speed is very erratic in the real world. So how is that affecting your penetration rate?
Actually, this is yeah, a very good example, and still there is not that much agreement on that. When you go towards the hydrothermal simulations, you usually use the hourly data because the hourly data is available. In many cases, even there is not availability of the hourly data. But as you said, if we reduce, I think in terms of sometimes the moisture content or in the long term, this hourly data would suffice. But if we think about the penetration, if we have, for example, if we have a rain intensity of, for example, 10 millimeter per hour in 10 minutes, and then we report it as an average in 1 hour, we reduce it by 1/6. And then we consider around 2, for example, millimeter per hour. And then it affects a lot the penetration, because generally the high intensity rainfall are in a short rain duration. So I think we expect that's why in new recommendations, or the limitation is that rather than going for hourly data, going for 5 minutes intervals, 10 minutes intervals of the measurement, at least to find out what's the real wind or even rain intensity, and then correlate it to moisture content and penetration. Yeah, I agree that it affects a lot.
And it will be in your experiment would be an underestimation due to this.
You know, at the, for example, I had hourly of the testing, the hour average. If we say that we have 10 minutes of an intense rain and then the rest of the 50 minutes is not raining, it probably having 10 minutes of the high intensity rain with a high penetration, and then the rest, because the rain stops, there is no penetration. In my case, I have lower penetration because the intensity of the spray rate is averaged in 1 hour, but I had the penetration in the whole hours. So I think it's a balance. We have the higher intensity and higher penetration, but if it's for the short period of time, then it's only limited to a 10 minutes or 5 minutes. While my experiment, I sprayed in a lower spray rate, but very continuously. So I think it's a balance.
Yes, I agree that the effect is probably difficult to estimate. And what I'm getting at, that you should make sure that not all of these imperfections point in the same direction.
Yeah.
So then in total, maybe you will have a completely.
Yeah. But I totally agree that the higher intensity rain, as it shouldn't be averaged, it's most probably lead to higher penetration or higher absorption rate, sudden absorption rate, rather than this average value.
Okay, thank you very much. I think I will stop there.
Thank you.
Thank you very much. And now to the reserve here.
Yeah, I would like to ask a couple of questions, but I will limit it to only one.
Nice.
Because I'm really hungry. Congratulations for your nice presentation. It was really nice and good explanations throughout this whole session. What about the preconditioning of your samples? Tore here brought up one question here about how figure number 2031, when you repointed the samples, you got a reduction in the rate of absorption. What about the preconditioning before the first and before repointing? How was it done?
Actually, all of the tests that I did, it was done in the laboratory area, environment, and there was not significant changes in the condition of the testing in terms of the temperature and relative humidity, even though I did a test that I rent from your lab space. So I did from all of the tests there. So there were a difference in the daily temperature and relative humidity, but not that much. But the conditioning or the curing, this is a very important aspects and parameters. Actually, this is the idea that I mentioned that we applied for funding. It's also related to the curing. As if we don't have a good curing, if the temperature is very low, like in Sweden or in Norway, in many countries, if we want to do the repointing or also the building a masonry wall, we do it throughout the whole year. And if the curing or the conditioning is not very good, then the bond is not well developed with the brick, and also the mortar. And if we want to go to the structure related aspects, the bond is not, the strength is not well developed during the curing time. So it's very important and affects a lot the results. But here I tried, because even though my test took around 2-3 years, so sometimes it was during winter period, sometimes the summer period, but all occurred in interior, so inside the lab. But if we do this in the outside, so this is actually the idea that we have now. What happens mostly with the lime mortar, natural hydraulic lime mortar, where they need a good temperature and a long period of time for curing and development its strength, then how it affects the results. Because yeah, the condition is not as good as the lab, definitely.
Okay, thank you.
Thank you. So thank you to the examination committee for the questions. Are there any in the audience who have any questions at the moment? No. Okay, here we have one.
Thanks, Mohammad. Very
Thank
nice
you.
presentation. Even though my field is the statistics and too far away from everything, I already agreed with your opponent that you have a really nice potential ability to really elaborate everything clearly. So what I would like to ask, when you have different conditions, different designs, everything, so it's good that you theoretically at least think about the potential outcome that you have, which is just the penetration, and put all these variables into together in one model, a statistical model, to see the result just by adjustment of these environmental effects. Maybe it's a good idea in future to do that.
Yeah, thank you, Mortaza. And it was a very good tip and information. Actually, I tried somehow to reach to a model or a more conclusive model, but the one difficulty that I had, for example, for one series of specimens, like series 1 specimens, each curve that you can see, it's the average of around 15-13 specimens. And then it was a very high scattered in the results. I got criticized a lot. It's not my fault, but always I got criticized why there is a high spread in the results. So it was somehow a bit hard, but I agree that because I tested, I think more than hundreds, 200-300 of specimens. So if I gather all in one series, then and consider all variations and the data, it might be. I tried to do it in the last paper that for all cracked specimens, it's around 65 specimens. I try to categorize them in one model and try to somehow average it with some coefficient of variation with some simple statistical methods and some p-values and to show the significance of the results and so on. But yeah, I will think about it. Thank you.
Anyone else who has any questions? No? Okay. Then with this, we conclude this part of the dissertation. And I would like to say thank you for a very good presentation, Mohammad, and also for a very, very good discussion, both from the opponent and from the examination committee. I'm sure that we could keep on further on the whole afternoon here, but instead we will split up now. So the examination committee will go its way and the rest of us will go for a lunch. But I have one final question to you.
Yeah, sure.
Based on what you have done and all the comments you've got here, and also I understand from your papers when you have written those, what would you really like to do now? No,
I talked honestly with Miklos, I think it was 2-3 days ago that talked about it. Yeah, if I don't think about the funding limitations, these limitations that we have, I really want to, because the more that I digged more into this topic, the more research ideas I found based on this topic. So if I had the access to some fundings, I definitely continue this work. Now we have honestly an unfunded projects, but it's the continuation of these projects where I can, yeah, probably Miklos showed somewhere. I built some of the larger specimens, and so there are more representative of real world masonry, and also with different workmanships and so on to show how it's done. And also I want to see the effects of water repellent, repointing, and so on. So I would really like to continue, and I have also had different ideas now, like the reuse of bricks, as we discussed with Inge about the circularity. So I hope that I can continue this research path, but also have some touches not only on penetration, because I got tired of penetration, but also on some related aspects to masonry and concrete.
That sounds very good. And I think you have got inspiration also from the
Yeah,
comments here
definitely.
today. So with that, we split up and see you perhaps, I don't know, I can lead the way to the food. Yeah. IKDC, Bryggan. It's a building not next to this building, but up further up north.
It's called the Design Centrum.
Design Centrum.
Yeah.
Yeah.
Yeah. We end the live session. Yeah.
Yep.
Yeah. So yeah.
We do that.
Yeah.
Okay. So thank you very much for this part.
Yeah. Thank you. Thank you.